All right, week 4 of distance learning. So today we're going to take a look at how to solve systems of equations, but this time, so at the beginning of the year, we looked at two linear systems, so two lines where they intersect. Now we're going to take a look at a line with something else. So parabola, a circle, all kinds of things, whatever else there is. So no new vocab, but our first problem here, we just have a linear quadratic system. So we want to solve the system of equations. So for this one, I'm going to show you how to do it algebraically. So by hand, no calculator. So these aren't the most simple thing to do by hand, mainly because you don't have all of your variables with degree 1, right? So the second equation here is our line. Everything's degree 1. In our first equation, though, it's not a line anymore. We have a y squared and an x squared, so it says quadratic, but really it's still technically quadratic just because the degree is 2. So anything that has a degree of 2 is quadratic still, even though it has more than just what a parabola would typically have. So this says linear quadratic, but it's really a line and a circle. Or, no, hyperbola, actually. So without graphing again, we're going to go ahead and plug them in. So the nice thing here is that our second equation has x by itself. We just, for the most part, we just had to move over the 2y. So we're going to subtract 2y from both sides. So we have x equal to negative 2y, or 2 minus 2y plus 2. So now we're going to take that, we're going to plug it into our first equation for x. So we have 4 times that thing, negative 2y plus 2 squared minus 16y squared equal to 25. So now what we want to do is actually square that binomial that's being squared. So that's going to be leaving the 4 outside for now. The first term squared, negative 2y squared, is a positive 4y squared. We multiply the two terms together. Negative 2y times 2 is negative 4y. Then we double it, and that's a negative 8y. And then we square the 2, so that's just going to be plus 4. Minus 16y equal to 25. So now we need to distribute that 4 inside, so we have 16y squared minus 4 times 8 is 32y plus 4 times 4 is 16. That equals minus 16y equal to 25. So now we need to combine some like terms. We're going to shift that 25 over to the other side as well. So we'll do that all together. So subtracting 25 from the only one that's a number, that's 16. And then combining like terms, we got a 16y squared. That's the only one of those. But we do have a negative 32y and a negative 16y. So combine those as well. So we'll leave the 16y squared alone because that's the only y squared. And then negative 32y minus 16y gets us, oh, that's y squared. I knew something was not going on right there. So I take that back. Sorry, go backing up here. So we have a 16y squared and a negative 16y squared. They're going to eliminate. So that makes things a little bit easier. So now we just have the negative 32y. And we didn't need to move that over either. So we got to backtrack a little bit more too. So we don't want to move the 25 over. We'll leave that over there. So now we're leaving the negative 32, and we're going to subtract the 16 from both sides. So we have negative 32y equal to 25 minus 16 is a positive 9. And then we're going to divide both sides by negative 32. So we're going to get a nice ugly fraction for us, but that's fine. So y is equal to negative 9/32. I didn't even box that. So now we know what y is. We just plug it into our second equation, x equal to negative 2 times negative 9/32 plus 2. So doubling that first one and getting the negative times the negative, so that goes away. So it's 18/32 plus 2. We're going to simplify that fraction before we add it. So that way, I always say simplify before you multiply. In this case, we're going to simplify before we add. So 18 over 32, this would be 9 over 16. And then we have this 2, so we need that in terms of sixteenths in order to add. So that'd be 32 sixteenths. And adding across the top gives us our x. 9 plus 32 would be 41 sixteenths. It's kind of ugly because both of our parts are a decimal, but it only crosses that hyperbola in two spots, or in one spot, I mean. So our solution is at 41 sixteenths negative 9 30-seconds. Now, this next problem is going to be the hardest one. I'm actually going to clear it out so that we can actually have more space to use to work on it. So this is a circle that's being intersected by a line, but it's going to cross it in two places. So Rosetta enters the highway 10 miles north and 12 miles west of the service tower for a radio station. She follows a straight path and leaves the highway 25 miles south and 8 miles east of the tower. If she averages 70 miles per hour and the range of the station is 15 miles, for how many minutes will she be in range of the station when she is on the highway? So that doesn't mean she's going to be on it and always have that station. She's going to be on it and only have that station for a portion of the time she's on that highway. So what we need to do, we have to first figure out, because we're trying to figure out how many minutes, and everything else is in distance and speed, we need to figure out where she enters the range, find the distance between those 2 points, and then figure out how long it is between those two distances at 70 miles per hour. So there's a lot to this. So the first thing we need to do is figure out the two equations. Then we'll use Desmos to make this a little bit easier for ourselves. All right, so again, we need to figure out our two equations, right? So the first thing we need to do is look at what's happening, right? So the line is her path on the highway, and then the circle is the radius, or is the distance away that the station can be heard. So it doesn't really tell us, but we're going to use the station as the origin. Or the tower, whatever. That makes our circle equation much easier. So now our circle equation is just going to be x squared, because it's at the origin, plus y squared, again at the origin, equal to our radius of 15 squared. So we don't even have to go any further than that. We can leave it just like that. Now, finding so that's our circle. Finding the line is not so easy. So what we need to do is figure out the points on the line where she enters the line. So that way we can use those 2 points to find the equation. So the 2 points we know, she's 10 miles north, so that's the y. We need to make sure of that because the work I've seen for this problem before is incorrect. It has it backwards. So the 10 miles north is great. The 12 miles west is negative, so it's negative 12, 10 is our first point. That's when she enters. And then she exits the highway 25 miles south. Again, that is our y value, but it's south, so it's negative 25. And then she is 8 miles east. East is positive, so that's 8. So that is our exits. The highway part. So now those 2 points are great, but they really don't matter. What we're really using those for is they don't matter in for the sake of the time she's listening to radio. They matter because now we can use them to find the equation for the line using the slope formula first. So we need to find our slope. So that's going to be y2 minus y1 over x2 minus x1, negative 25 minus 10 over 8 minus negative 12. Again, I subtracted a negative, so I changed to adding. So that's negative 35 over 20. 35 divided by 2 is 17. So 35 divided by 20 will be, and it's negative 1.7. 1.75, sorry. So now we have our slope. We can use point slope to find the equation. So y minus y1 equal to m times x minus x1 is point slope form. Our y1, it doesn't really matter which one, we can use the positive or negative one, or the enters or exits point, but we'll use the enters since that's the point she starts at, right? Negative 10 equal to our slope of negative 1.75 times x minus negative 12. So leaving the left side alone for now, distributing the negative 1.75 minus, and negative 1.75 times 12, or just 1.75 times 12, would be 21. So now we just need to add 10 to both sides, and our line is at y equal to negative 1.75 x minus 11. So now we have our two equations, right? I'm going to box them in blue, just so we know which ones we're using. So now we're going to jump over to Desmos to make this a little bit easier. And we're going to graph these two on Desmos, just to make this a little bit easier on ourselves. So let me get out of this and switch over to Desmos. So our equations were x squared plus y squared equal to 15 squared is 225, but I'll leave it as 15 squared for now. You can't see it on the graph just because it's a larger circle. And then we need to do our line, which is going to be y equal to negative 1.75 minus, I read the x 11. So there is our path, and there is the radius of the tower. So we can get our points where they intersect here and here. So those are the 2 points that she enters the radius, or the area of the radio tower on that highway. It's a pretty straight highway, but it works, okay? So now let's go back to our work here, okay? So what I'm going to do is wipe this clean. Not really, I'm just going to give myself a little more space. I want to leave all this stuff on here so we know what we're looking at. I'll shift it all up though. So those 2 points we just saw in our graph are at negative 11.67, 9.423, and 2.194, negative 14.839. So now we have our two intersection points. We need to find the distance between these 2 points. So we have to use our distance formula. So that's going to be x2 minus x1 squared plus y2 minus y1 squared. This is going to be kind of ugly just because we have all these decimals in here, but it is what it is. So x2 would be 2.194 minus negative 11.67 squared plus negative 14.839 minus 9.423 squared. So doing the math here, this is going to get us square root of 13.864 squared plus negative 24.262 squared squaring those gets us some more decimals, 192.2105 plus 588.6446. Adding those up, get us 780.85544. Now, some of this I didn't round when I was actually doing the calculations, but you get the idea. And then our number 27.9438 miles. So now that's the distance she's on the road. We also know that velocity, or speed, is equal to distance over time. Her velocity here is 70 miles per hour. We now know our distance, so we just need the time. So time is equal to distance over velocity, or 27.9438 miles over 70 miles per hour. This is going to give us our time in hours, and then we just have to multiply it by 60 to get minutes. So 0.3992 hours, which translates to, after multiplying by 60, to 23.95 minutes. A lot to that, right? Have to find the equations first, find the points where they intersect, find the distance between those 2 points, and then find the speed, or find the time in hours, and then transferring it to minutes. A lot to that one. Promise the next three problems, are not so bad. Because we're just going to jump over and use Desmos. So this first one here, solving the system of equations. Again, this time we don't have a linear quadratic, we have quadratic. So that first one's a circle, the second one's an ellipse. So that means instead of only having 2, it could have 4 solutions. It could only have 2. It's not, if it has 1, it's just because they just touch each other in one specific point. So it's possible to have 0, 1, 2, or 4 solutions when you're looking at a quadratic system, especially when those quadratics are circles and ellipses. So let's take a look at that on Desmos. So here we go back over to Desmos, our friendly calculator system. So we can go ahead and get rid of the ones from the last problem. And now we have 2 more equations. So our circle, x squared plus y squared, equal to 16. It's a much smaller circle. And then our ellipse, 4x squared. Again, these ones are actually both centered at the origin, so that's kind of nice. Plus y squared equal to 23. So there we go. So you can see that we do have 4 solutions, like I mentioned we could have. And that's fine. It happens. So here are our 4 solutions. So the nice thing here, because they're centered at the origin, notice that all the numbers physically are the same. The absolute values of the numbers are all the same. The difference is that they are just dependent on which quadrant they're in. So our solutions, let's go back to our work here. Oh, let me do that. Hold on. Press the right buttons, Mr. G. So we have 4 solutions. First one is at the positives, 1.523, 3.697. Then there's one in quadrant 2 where x is negative and y is positive. And there's one where they're both positive or negative, sorry. Already got the positive one. And then there's one where the y is negative. Jeez, I can't say things right now. And there's our 4 solutions. Super easy using Desmos. We're going to do that same idea here. Actually, we're going to graph these ones because they're shading. So they're pretty easy to graph. The first one's a parabola. It's just shifted up 1. The second one is a circle with a radius of 3. So the parabola, it is just less than, so we do have a dotted parabola. And it's a shifted up 1. So it looks like this. We just go to the right and left 1, and up 1, to the right and left 2, and up 4 from the vertex, like we do with our parabolas all the time. And then it's a dotted line, so let me make it dotted here. And then it is specifically greater than, so everything above it or inside of it is shaded. And then for the circle, center's at the origin, radius is 3 in all directions. So there's our circle, and it is less than or equal to, so that's good. And less than with a circle means it's shaded inside. So everything's shaded inside, and that means our overlap is what we really want, and that is going to be this little tiny wedge right here. I'm going to do that one in blue. But keeping in mind, around the parabola doesn't count because it's not for both. But the circle outline through there is okay. And that's it. The next one, same idea. We have a circle again and an absolute value equation. We haven't had one of those in a while, but still not too difficult to graph. It's just the plus or minus version of that line, right? So again, we have only inequalities here that are just the inequality note or equal to's. So the first one's a circle, center at the origin again, and our radius is 4. Our graph actually doesn't allow that to happen, but that's okay. We'll make do with what we got. So we'll make our dotted line circle here. That's a radius of 4. And there it is. This one's greater than, so it's including everything outside of the circle. Then the absolute value one, we've got, it's a slope of 1 and up 4. So y-intercept is 4. So once we hit the x-axis, we just go back up. So really the plus 4 means it's shifted to the left 4, but that's fine. And it's still a dotted line, so let's go ahead and connect our dots. So do this freehand. And this one is greater than, so again, shaded above it. So that means our answer is everything that's not quite on the circle here. Everything above it and also not including the line that is part of the absolute value. It's kind of hard to tell there, but it does cut off at the circle. Somewhat. There we go. A little better. And there you go. And that is it for these notes. See you next time.